Continuing our discussion of shell scripts, we said there was a problem with this that was generated. And the first problem that you'll notice is that it has a bunch of zeros, and a zero is a null. If you're using something like stir copy, that null will stop the copying operation, and it's going to be a problem for you. So what can we do? We have to rewrite our script slightly to, number one, get rid of the nulls. And another issue is that we cannot have any absolute addresses for things such as our message. So how can we fix that? Let's go back to our assembly. Here's my simple 32-bit assembly again. If I look at this version does the same thing, but it doesn't generate any nulls. And here's how it works. Instead of moving the value of 4 to EAX, I replace that one line with these two lines. First, I XOR EAX with itself. That will cause it to zero out. There's an AX, which is 16 bits wide. There's also an A low, which is 8 bits wide or 1 byte. There's also an AH, an A high, which is also a byte. So what I can do when I have a small number to move into a register, I just XOR it, zero it out, and then I move the value to the smaller size register, AL in this case. Then I do the same thing with EBX. I XOR it and move 1 into BL. We'll come back to this next bit in a second. For now, we're going to skip over that. Here we have EDX. I XOR it with itself, and then I actually have to calculate the length and put it in there. So I have 17 being moved into DL, and I make my system call. Here for my exit, XOR EAX with itself, move 1 to AL, XOR EBX with itself, which makes my return code 0, and I make my system call. So let's go back to this guy. Now, earlier, what did we do? We said, I'm going to move the address of message into ECX. Now I've changed it. I have this very funny looking thing where I jump down here to this label. And then I immediately call to the line right after my jump instruction. So there's a couple of things going on here. First of all, you'll notice that this says jump short. You're allowed to jump forward 128 bytes or backward 127 bytes. This eliminates the need to have an absolute address. So I jump down here to right before my message, and I immediately call, but not jump, this. So we know from past videos that whenever we call a function, our return address is pushed onto the stack. What's my return address? It's the next instruction. In this case, it's the address of my string because it comes right after the call. So I call return shellcode and I end up here. The first thing I do is I pop the top of the stack into ECX, and notice that's equivalent to what I had up here. I had a parameter, I needed it in ECX. So what I've done is I've gotten the address of this string into ECX from my jump, call, pop. So now I don't have any absolute addresses in my shellcode, which again is a bad thing because I have no idea where the shellcode is going to be run. If I can get the shellcode to any place that's executable and cause someone to go to it, I'm happy because it worked. Let me go out to my shell and I want to compile it to simple 32, no, null. And I will link it. I'll take simple 32, no, null. And if I rerun my script, simple 32, no, null, sure enough, there are no nulls in this script. If I had an exploit against a Linux system, I could take this and cut and paste this string and send it, and that would be a great payload. We're going to take another brief break, and when we come back, we'll continue our discussion of Linux shellcode.